Hi everybody, this is Mr. Short. Today we're going to look at some notes that we took earlier this week. If you take out these notes, Introduction to Atomic Structure, we're going to focus mainly on objectives 4 and 5. So I'm going to go ahead and highlight those right here. Objectives 4 and 5 have to do with definitions for terms atom, ion, and isotope. And then also we're going to take a look at how ions are formed, the process that forms ions. All right, I actually want to scroll down first and emphasize that the way that we define atoms of a particular element is solely based off of the number of protons that are inside the nucleus. And we've got a nice picture of that right here. So if you take a look, the key tells us that this little white dot right here is a proton. And each one of these pictures right here has only one proton in the nucleus. Here, here, and here. Remember, in standard format, the number of protons is the atomic number, and that goes in the lower left-hand corner, which is why each one of these is a hydrogen isotope, and we're going to talk about the term isotope in just a minute. If we take a look at the term isotope, our definition of isotopes is, or are, isotopes are different nuclear forms of the same element. That means that the nucleus is going to be different. So isotopes of the same element are going to have the same number of protons, but different numbers of neutrons. So again, see how each of these hydrogen isotopes has the same number of protons, 1, 1, 1, but different numbers of neutrons, 0, 1, and 2. Now remember, the mass of an atom, ion, or isotope comes primarily from the particles that are in the nucleus, which is right here. Said another way, the mass only comes from protons and neutrons. So because there's only one proton in here, mass is in the upper left-hand corner. We've got a mass of 1, a proton and a neutron, a mass of 2, 1 proton, 2 neutrons, a mass of 3 particles in the nucleus. So again, isotopes of the same element, they have the same number of protons, but different numbers of neutrons. Okay, we're going to flip to a PhET simulation now, and we're going to emphasize that concept. If you take a look right here, when I put a proton inside this nucleus, notice that it changes it to hydrogen. It wasn't anything before, but now that it's got one proton inside the nucleus, it's hydrogen because hydrogen is element number 1. It has one proton. It has an atomic number of 1. And it doesn't matter how many neutrons I add to this, it's still hydrogen. It also doesn't matter how many electrons I add to this, it's still hydrogen. Okay, so remember, atoms of a particular element are determined only based on the number of protons in the nucleus and not by any other factor. So if I go ahead and I add a second proton to this, we would predict that it would no longer be hydrogen and it would turn into helium. Now it's helium. And if we add another one, it would no longer be element 2, helium, it would be element 3, lithium. But again, it doesn't matter how many of these other particles I put in there, because the only way that atoms of a particular element are determined is based on the number of protons and not by any other factor. Okay, I also want to emphasize the concept of isotopes. So remember, isotopes of the same element have the same number of protons but different numbers of neutrons. So, for example, this is a model from this picture right here of this one. It's got one proton and one electron. And you can see that this is hydrogen. But we can also turn this into hydrogen with 2 particles in the nucleus. And now you can see it has a mass number of 2. So let me kind of back that step up just a second. If it's only got 1 particle in the nucleus, it's got a mass of 1. But if it's got 2 particles in the nucleus, it's got a mass of 2. And this is now a model of hydrogen 2. And we can also model hydrogen 3, which is right here, by putting a 3rd neutron in there. But let me emphasize that the electrons, because they're so tiny, their mass is said to be about 1 over 2,000 atomic mass units. It doesn't matter if I take this away or if I add a bunch of them, because they don't contribute to the mass of an atom, ion, or isotope. Okay. So now at this point, what we've done is we've reviewed how we define atoms of a particular element, and we've gone over the concept of isotopes. Now what we're going to do is we're going to compare and contrast the terms for atoms and ions. So remember, atoms will have an equal number of protons and electrons, and because they've got an equal number of positively charged particles and negatively charged particles, they have no charge. So see how 19 positives balance 19 negatives. It is a neutral atom. Same thing here, 17 positives, 17 negatives. It's a neutral atom. So that's the definition of atoms, no charge because equal number of protons and electrons. In contrast, ions have a charge. They're formed by a gain or loss of electrons, never protons. So we can swap out the electrons, either gain or lose, but we can't swap out what's inside the nucleus. Okay, so for example, if we compare neutral potassium atom to potassium ion, you can see that it must have lost an electron because it has 19 electrons here, but 18 electrons here. Likewise, neutral chlorine atom, it has 17 electrons. It must have gained an electron because now it's got 18 electrons. Well, that sounds like a good partnership because this one wants to lose an electron and this one wants to gain an electron. So let's take a look at that real quick in the build an atom PhET simulation. Okay, I'm going to hit reset and I want to take a look at net charge in just a minute. Okay, let's say that we're talking about a very simple neutral atom, which is hydrogen. When I click on net charge in neutral or ion, you can see it's a neutral atom right here because we've got a balance between the positively charged particle, the proton, and the negatively charged particle, the electron. You can see that balance right over here. One positive balances with one negative. But look, if I lose this electron, now this turns into a positively charged ion because it's got more positively charged protons than negatively charged electrons. Okay? Conversely, if it gains an electron, now it's got an extra electron. It's got 2 electrons compared to only 1 proton, and for that reason, it's going to be a negatively charged ion. Okay, so remember, our definition of the way that atoms turn into ions is that ions have a charge, and the way that they get that charge is by gaining or losing electrons, never protons. Okay, to emphasize that concept, I want us to take a look at this video by Tyler DeWitt. We're going to start the video at about 55 seconds. And again, in this video, he's going to emphasize how neutral atoms turn into charged ions.
Let's look at the atom sodium. Sometimes when I'm talking about atoms, I'll just draw them as the element name inside a circle to indicate that that's the atom I'm talking about. But for our purposes, we're going to want to zoom in a little bit more. Here I've drawn 2 things in this zoomed in version of the atom. I got protons here in the nucleus in red, and then flying around on the outside, I have these electrons, which I've drawn as black dots. If you know a lot about atoms, you might know that I've left out the neutrons, which also live in the nucleus. But it's no big deal because neutrons don't have a charge at all. They're neutral, so they're not important for what we're talking about here. Anyway, right now, sodium has, if we counted them, 11 protons here in the nucleus, and it has 11 electrons flying around outside. So the number of protons equals the number of electrons, which means that my total net charge is 0. They cancel each other out. And so something that has no net charge, like this sodium atom, we call it neutral. Okay? But here's what can happen in sodium. You see this electron right here? It can lose this electron. It can lose it, and it flies off and usually goes into another atom. So let's look at what happens when this electron here gets lost. And now we're going to end up with a sodium atom that has 11 protons, just like it did before. But now because it's lost this electron, it used to be here, that was here, now it's not here anymore. Now it only has 10 electrons. So now the positive and negative charges don't balance out anymore, and I'm left with more positive charge than negative charge. So this thing now is going to have a charge of +1, one more positive charge and negative charge. And so I can write this, if I want to talk about the atom, I can write it as Na plus to show that it has a positive charge, whereas this, when I'm talking about a neutral atom, I'll probably just write Na. So Na plus here is an example of an ion. It's an atom that has a charge, and it's a specific type of atom. We have a name for this. We call it a cation, which is what we call an atom. An ion, what we call any ion that has a positive charge. Okay? Let me show you another example. Okay, so here's an atom of oxygen. The atom that I've drawn here has 8 protons here in the nucleus, and it has 8 electrons outside. So we have the same number of protons and electrons, which means that the total charges balance out. Plus and minus balance out. So I have a net charge of 0, and I can say that my oxygen atom is neutral. It has no net charge. But oxygen can gain or lose electrons, and actually it really likes to gain 2 electrons. And here's a picture of the oxygen atom after it's gained 2 electrons. And now it still has 8 protons in the nucleus. And if I count up these electrons, it now has 10 electrons instead of 8, which it had before. So now the protons and electrons don't balance out anymore, and I have more negative charge than I have positive charge. I've got 2 more electrons and protons, so that means that my total net charge is going to be 2 minus. I can write the symbol for this ion as O2 minus to show that it has a 2 minus charge, whereas this neutral guy over here, I can just write O. This is an ion because it has a charge, and there's a specific name for it. We can call this an anion, which is the word that we use to describe a negatively charged ion that has more electrons than protons. Okay.
Okay, so Tyler DeWitt there did a really good job of summarizing the concepts of how atoms turn into ions. So remember, ions have a charge, and they're formed by a gain or loss of electrons, never protons. All right, thanks a lot, guys. Have a great day.